by writing your code either in MapReduce or in Pig or in Hive script. And once you have processed that, once you got some results out of it, you may want to store them back onto some database tables. So you can use Scoop to export the data back from HDFS to appropriate tables, any relational database table for that matter. And the other set of sources, I mean, where you can see a lot of data getting generated are streaming sources or IoT devices. Like if you have, I mean, assume that you have smart cars, which will be having sensors, so that will be generating huge amount of data. So you may want to capture that and wanted to analyze that later. So in that case, if at all you wanted to analyze or process that data through Hadoop, first of all, you have to get that data to Hadoop, I mean HDFS. So there are several tools which will help to capture the data and store it onto and bring it onto HDFS. So Flume, Kafka, Kinesis are such kind of tools which will help to get the streaming data onto the HDFS. So like that. So there are several other components which I haven't put in the ecosystem, like Woozy and all. So we'll also discuss about them. So any questions on this ecosystem components? Can we move on? Okay, so there are several releases happened for Hadoop so far. The latest one is the 3.1. So these are the previous well-known releases of Hadoop. So currently we are at 3.1. So in our demo, in our classes, we will be using Hadoop 2.7.1. So what are the key attributes of Hadoop actually? So what we said about Hadoop, we can use Hadoop to analyze huge amounts of data. So irrespective of that, how much ever the size of the data, so the system should be redundant and reliable. As we are going to store our data onto HDFS, so we will be storing the data in a redundant fashion. So for each and every chunk we'll be having 3 copies. And even if some servers are down, you can still get access to the data if you have at least 1 copy of the data available. And the system should be scalable enough. So it is very easy to add any new machines or to remove any existing machines from the Hadoop cluster. It is very easily scalable. And most of the times it is batch processing centric. So we will be processing terabytes and petabytes of data. So it would actually take a couple of hours to finish the execution. So obviously it is like submit the job and come back after a while and then look for the results. So it is batch processing centric. So irrespective of the size of the data, it should be easy to program. So as we have discussed, you just need to express your code in terms of map and reduce code. So you don't need to bother about anything else. So it is having an easy way of programming. And it runs on a commodity hardware. It doesn't require any special blade servers or server class machines. Any commodity machines that you have, you can just prepare a cluster out of it and you can start processing your data. So that it follows an important feature called speculative execution. It is very much important. I think when we are discussing about MapReduce programming, we will discuss more on the speculative execution. So these are some of the key attributes of Hadoop. And then, so in one of our previous diagrams, we have seen a company called Cloudera. So what is the business of it actually? So most of the Hadoop components, ecosystem components that we have discussed are open source ones. So those are not proprietary softwares. So that means to say, there is no dedicated sales force or marketing force